Nice to meet you, Jeremy and William. I think both of you are on the young side. I think one of you said you're grade 6 and one of you are grade 8, right? So before we do the grade 10 math, I do kind of want to make sure you guys have your basic math fundamentals down so that you'll understand what we're talking about once we do get into grade 10 math, okay? So have you guys learned, I know William will have learned it because he's in grade 8, but Jeremy, have you learned about sequences and linear sequences? Like for example, if I gave you a sequence, it's kind of like 1, 3, 5, and 7. What's my next number, Jeremy? Like this should be quite easy.
9.
9, good. And then suppose the teacher asked you, what is the 57th number? Is there a good way that we can solve this algebraically instead of having to list out all the way to the 57th number? That'd be kind of annoying. What's my equation? You guys in school may have called it general term, or sometimes people call it linear equation. Sorry, you were about to say something. I heard 2.
You can multiply by 2 for 57 and plus 1.
So you have to multiply 57 times 2 plus 1. Yes, but if we wanted to write that as an algebraic equation, do you know how to do that? So that I can solve for any number, for the nth number, for the nth term. So instead of just specifying the 57th term, what if I want to solve it for the nth term? So it doesn't matter which one it is. All we have to substitute is for the n.
Wait, 2n plus 1?
2n plus 1? Well, let's see if that works, because if, by your logic, if n is equal to 1, then that means the answer should be 2 times 1 plus 1, which should be equal to 3, right? And my first term is not 3. My first term is 1. So unfortunately, 2n plus 1 doesn't work. Can you think of another solution which would work? Hi, Sherry. So in this case, Jeremy, the answer is actually 2n minus 1. Because our first term, this is our n, right? N is 1, 2, 3, 4. Our first term is equal to 1, so it's actually 2n minus 1 in order for us to obtain this equation. Okay, so this is something that you'll probably learn in grade 7 and grade 8. Usually your school will refer to this as general term. And then once we have the general term, the next thing is, well, what the teacher will usually like to see what it looks like on a graph, right? They want to represent it on a graph visually so that people can know what it looks like. So the easiest way to do this, this is how you'll learn to do it in elementary school, is you will construct a table of values. In this case, our table of values is kind of already here. Hopefully you know that this is the x-axis and this is the y-axis. So x runs left, right, y runs up, down. And then when x is equal to 1, our y, our value is equal to 1. So we have 1, 1. And then when x is equal to 2, y is equal to 3. When x is equal to 3, y is equal to 5. So that's 1, that's 3, that's 5. And then that's 1, that's 2, that's 3. And so on and so forth. Okay, and we'll notice that when x is equal to 0, it's going to go through -1. And then all we have to do is play connect the dots, and we will have our linear equation. This is going to be our line. Does this concept make sense, Jeremy? Like this is just a graphical representation of this algebraic equation. Because we do need to know how to draw these on a graph, right? To show people how does this look if we were to illustrate. Hi, Sherry. Hi, I didn't get a chance to speak with you earlier. My name is Michael. May I ask what grade you are, Sherry?
Grade 8.
You're in grade 8? Okay, so everything that I said just now, you probably already learned it and you probably have a decent understanding of it. So again, we are reviewing a little bit about linear relations first before we go into, I guess, the introduction into grade 10 math. So it is going to be a little bit challenging for all the students here, but that's okay. If you find it too challenging, it just means that you guys need to learn grade 9 math instead of grade 10, right? So it's really not that big of a deal. So the question is more for Jeremy, I guess. Jeremy, does this concept make sense to you that we can write this algebraic equation in order to solve for any term And this algebraic equation at the same time can be represented graphically over here like this. Because you haven't done this in school yet, right? So you haven't plotted these in a graph, so it's going to be a little bit challenging for you. William, Sherry, you guys have plotted these in schools already, right? Do you guys understand how to plot a straight line?
Yeah.
Yeah.
Yeah, so both of you guys have practiced this a few times in school, so it's probably a little bit easier for you guys, right? Okay. So again, Jeremy, if you're unable to understand this concept, it does mean that you might be a little bit too ambitious in trying this class, and you may need to try something a little bit easier, okay? But now that we know how to plot the linear equation, the first thing that we usually have to do in grade 10 is figure out how do we solve for linear systems. So before we go into linear systems, maybe we should just review a little bit about how to solve for a linear equation. Like suppose I have the equation 2x plus 3 is equal to, I don't know, let's say 7. Who knows what x is equal to? What's x equal to?
X equals to 2.
2, good job, because 2x is equal to 7 take away 3. 2x is equal to 4, and then therefore x is equal to 4 divided by 2, which is 2. Very good job. Everyone got that one correct. Well done. So that's for one equation, right? What happens if we have more than one equation? That's the real tricky part, right? So what do we do if we have more than one equation? So we've already established that the equation of a line looks something like 2n minus 1. Okay, this is kind of what the equation of the line looks like. But in high school, we usually call it in terms of x and y. So we usually write it as y is equal to 2x minus 1. So instead of n, we don't usually use the term number n in high school. We'll use x. And then instead of the value, we'll just call it y. Okay, so it's the exact same thing as what we just wrote previously with the 2n minus 1. Except instead of saying the value or the number is equal to 2n minus 1, we'll say y is equal to 2x minus 1. And again, William and Sherry probably have a little bit of experience with this. So having established that y is equal to 2x minus 1, what if we have another line? What if we have something like y is equal to 3x plus 2? And then the teacher said, solve for x and y so that you satisfy both equations. So in other words, x and y, you need to find one set of answers for x and y, and it has to work for both equations. So how do we solve that? Well, there is a graphical way to solve it, and that is we can take a graph, and we can plot both lines. So let's call this number 1, and let's call this line number 2, okay? So y equals to 2x minus 1. Again, we know that the y-intercept is going to be a negative 1. And it's going to have a slope of 2. And again, if you guys don't know about these terms, because it's technically you're only learning in grade 9, so you guys are a little bit ahead. But this is the slope. So we know the slope has a rise of 2 over 1. And then the y-intercept is equal to negative 1. Okay, so that means it's going to pass through negative 1. And it's going to have a slope of 2. So it's going to go up by 2 units and across by 1. Okay, so this point is 1, 1. Okay, but that's not too important. I'm just illustrating this as a sketch in order to kind of teach you guys how to do it graphically. We have another slope. So it says over here, y is equal to 3x plus 2. So again, we have plus 2. And then we have a slope of 3. So it's going to go a little bit steeper. It's going to go something like this. Okay, so this will be line number 2, and this is going to be line number 1. So the question of where do these two, what are the x and y coordinates such that it satisfies both equations? Well, it's going to happen at the point of intersection. Because at the point of intersection, we're going to have a set of x and y coordinates that satisfies both lines, right? So we can do this graphically. You can take a sheet of graph paper, you can plot out both of the lines, and then afterwards you could just see where they intersect, and that will be your answer. So that's a very valid way of doing it. Okay. That said, it's very tiring to always be plotting things, right? If we have to plot graphs every time we have to solve this question, I don't know, I would be tired at least. So the question is, can we solve it another way? And the answer is yes, we can solve it through algebra, right? Because algebra is always the faster way of solving things. So what we need to do is we need to apply a strategy known as substitution, okay? Because we know that y is equal to 3x plus 2, technically I can replace the y up here with 3x plus 2, right? Because these two are both y's. So I can replace them. So that means I get 3x plus 2 is equal to 2x minus 1. And now all of a sudden I have one equation with one variable. And this, I already know you guys know how to solve. What's my x in this case? Can anyone solve for x for me?
-3.
Oh, very good. Wow, I'm impressed. Okay, so we have 3x minus 2x must equal to -1 minus 2. All I did was bring the -2 over here and the 2x over here, for those of you who aren't trying it. Okay, so we got x equals to -3. Now that we have x equals to -3, substitute it back into 1 or 2. It doesn't matter which one you substitute it in. You will get the same answer. So we have y is equal to 2 times -3 minus 1. So that must mean it's equal to -6 minus 1, which is -7. So my final answer is x is equal to -3, y is equal to -7. And you'll find that these two numbers, -3 and -7, satisfies both equations, okay? And you could try it. So we have -7 is equal to 2 times -3 minus 1. That's true. And let's look at the second one. We have -7 is equal to 3 times -3 plus 2. And that's also true because it's -9 plus 2, which is -7. So that means this final answer is the correct answer. I know that when x is -3 and y is -7, it satisfies both conditions, and that means that's the point of intersection. Does that make sense for everybody?
Yeah.
Yeah? Okay, good. So obviously the question is, well, why do we need to learn this, right? Isn't this kind of useless? Like who actually needs to learn this? And the answer is it depends, right? Because what happens is, suppose you guys all have cell phones probably, right? I don't know. I think elementary kids all have cell phones these days, right? Suppose you guys all have cell phones, and you guys are shopping around for cell phone plans, okay? And then what happens is you guys go to Win Mobile, and Win Mobile says, oh, we have a plan for you. Our plan is real simple. For every gigabyte of data you use, we charge you $5, okay? So it's just $5 per gig. Oh, that sounds really expensive, actually. Let's change that to $2. That doesn't sound realistic. Okay, so it's $2 per gigabyte. So the equation for this line, we can call y equals to 2x, because it's for every x is the number of gigabytes, the number of gigabytes used. And we can say y is the cost, okay? So the cost is going to be equal to 2 times the number of gigabytes that you use. So when you use 1 gigabyte, it's going to be $2, okay, whatever. And then you guys go to another cell phone carrier. You guys go to Rogers, and Rogers says that, well, we have a different plan. It costs $10 at the beginning of the month, but what happens is we're only going to charge you let's say $1 per gigabyte. Okay, so it's going to be like this. Again, these lines are horribly drawn. Okay, please do not base it off the graph. You're not going to get an accurate answer from my drawings. But let's say the Rogers plan is $10 up front, but then they only charge you $1 per gigabyte. That's pretty good, right? So obviously, even without doing any calculations, you guys probably already know that if you're not going to be using a lot of data, it's probably better to go with Win Mobile. Okay? It's probably better to go with the orange one. I think that was Win, right? I think I said Win. Oh, they don't exist anymore. Freedom. So Freedom Mobile. Okay, but it's better to go with Freedom if you're not using a lot. But it turns out if you use a lot of data, it's actually cheaper to go with Rogers, right? So the question is, how much data do you need to use before it becomes more worth it to use Rogers? Does anybody know? Like, sure, you could list it. You could say, oh, if I use 1 gigabyte, then Rogers is $11 and Win is $2. If I use 2 gigabytes, Rogers becomes $12 and Win is $4. We can keep listing it until we can see when it's going to be more worth it, right? It's eventually going to catch up. But again, there's a faster way of doing it, right? And the faster way is, why don't we just determine the point of intersection? Because this point of intersection must represent the time when both carriers charge the same, right? So it's going to be a certain amount of gigabytes, and the price is going to be exactly the same for those 2 carriers. After that point, we will know that Rogers is going to be more worth it. And everything before that point, we know that Freedom Mobile is more worth it. Okay? So again, the whole point of learning about linear systems is so that we can solve equations like this without needing to list everything. And the nice part about being able to draw it graphically is that even for people who don't really understand math very well, they like to see graphs, right? They like to see pictures. And it's very obvious from this picture that if you're going to be using Rogers beyond a certain number of gigabytes, the cost is going to be cheaper. So people like to see pictures in order to help them understand the entire situation. Because if you write the algebra, like, I don't know if you've ever been to a Rogers store and you saw an algebra question there, but most people will probably get very confused, right? People probably wouldn't like that very much. Whereas if they show you a graph saying, this is how much we charge, this is how much the competitors charge, you can see that we are cheaper in the long run, at least. People like that. People will like to see that, okay? So now the question is, who can solve this for me? When does the 2 plans cost the same, essentially? At what number of gigabyte usage? Does anybody know? Again, my first equation can be represented by y equals to 2x. My second equation, the Rogers equation, can be represented by y equals to x plus 10, because it's $10 as the base fee up front, plus $1 per gigabyte. So that's 1x, but we never write 1x, okay? We always just write x. So if any of you guys are still writing 1x, please stop. So now that I told you guys this equation, who can solve for my x and y using the technique that we just discussed?
X equals 10 and y equals 20.
Y equals 20.
Oh, very good. All of you are very, very sharp. So again, we use substitution. We replace this with this. So we have x plus 10 is equal to 2x. Therefore, x must equal to 10. Now that we know x is equal to 10, substitute it into 1 or 2, doesn't matter which one, and then you guys figured out that y equals to 20. So you see, if you guys are only going to use exactly 10 gigabytes per month, it doesn't matter which carrier you use. You're going to get charged the same. If you're planning to use more than 10, please pick Rogers. If you're going to use less than 10, please pick Freedom, because obviously it's going to be cheaper. So this is the basic idea behind linear systems and why we need to learn it. This is a very simplified example of linear systems. They do get more complicated. I'm not sure if we're going to have the time to go over all of them today, but today, at the very least, we can introduce you to how to solve linear systems through 2 techniques known as substitution and elimination. These are, generally speaking, techniques that you learn either in grade 10 if you're in the public school system, or if you are in a private school system where you're going to be doing IB math, you will learn these techniques in grade 9. Okay, maybe even earlier, maybe even grade 8. It depends on the school that you go to, but the public school system does teach it a little bit slower. So we've just discussed a little bit about substitution. How about let's practice a few questions where maybe they're a little bit more challenging. Probably not too challenging for you guys. It sounds like you guys have a fairly strong grasp on the material. If you guys can solve these, that means your algebra is quite strong. But for Jeremy, it's quite evident to me that maybe you don't know how to graph these yet. So that means you are missing a little bit of grade maybe 7, 8, and 9 knowledge in order to be able to represent these algebraic equations as a linear equation. Okay, so you do need to be careful for that, Jeremy. Your algebra seems very, very strong. You have good math fundamentals, but I think you just never been taught how to graph it. So unfortunately, graphing is super important in high school. Grade 9, 10, 11, 12 is all about graphing. All of functions is about graphing. So you cannot skip the graphing portion. I don't know why they focus that much on graphing, but that is just the case, all right? So let's try one or maybe two or three of these questions, okay? And again, it's just one for each person, so it's not gonna be a lot. So again, Jeremy, if you could try number A for me. William, if you're still here, can you try B for me? And Sherry, can you try C? Do we have any other students? I don't know, I didn't check. Chang, why are you here? Chang, you know we don't have class today, right? Yeah, William?
I don't see A, B, or C. I still see the representing linear relations 1.1.
I must have not been sharing my entire screen. I apologize. I only shared the PDF, I think. Okay, thank you. Okay, first share the entire screen. Okay, now can you see it?
Yep.
Okay, so Jeremy, this one, I'm sorry guys. I usually share the entire screen. And then I think I clicked the wrong thing earlier. And then Sherry, you could try C. Chang, I'm not sure why you're here. You could try D though. Actually, I'm not sure D is solvable. Don't try D, Chang. I don't think that's doable with your current knowledge. You'll learn it really soon, Chang. Chang could do 2 if you want to, as practice. It's good practice. But you should be taking a day off. So again, the questions are not as straightforward as the ones that I gave you. You may need to rearrange the equations before you can properly solve for them. After you solve for your x and y, my recommendation for you guys is to get used to double checking your answers by putting it back into the equations, okay? Because there's no excuse to get these questions wrong, because you can literally check your own answers, right? All you have to do is plug them back in the equation and see if it satisfies the equation. So if in the future you're getting these questions wrong, it just means that either A, you didn't double check your test, or B, you ran out of time to double check your test. In which case you guys need to work on your time control and your efficiency when doing these math problems, okay? There's no excuse to be getting these questions wrong. Everyone knows if your answer is right or wrong. So there's no reason why we're ever submitting a wrong answer. Yeah, William?
How much time do we have to do it?
Oh, it doesn't matter. You take as much time as you need. Especially you. You're in grade 6. Like, you don't have to give yourself time.
No, I'm in grade 8.
Oh, I
So
apologize.
yeah, I was wondering.
Oh yeah, William. Sorry, it's Jeremy. That's grade 6. Yeah, no, you guys take as much time as you need because it's relatively new for you guys, right? Before, when you guys are working with solving for equations, at the grade 8 level, you guys only solve for one variable. So you guys have one variable and one equation. Remember, if you have 2 variables, then you need 2 equations to solve. Okay.
No, but like I'm asking, like when do we, like how do we know when we're talking?
Oh, you can just give me your answer anytime. Like if you finish, you can just tell me your answer.
Oh, okay. So
Yeah.
can I tell you now?
Yeah, of course.
So for B, y is -1 and x is 9.
X is 9. Did you double check your answer?
Yeah.
Yeah. Okay, great. So you say that y is negative. Oh, x is 9. Sorry. X is 9. Y is -1. So that's 4. -4 times -1 is equal to +4. 4 plus 5 is equal to 9. And then x is equal to 9. So that checks out. This one, x is equal to 9. 2 times -1, so that's -2, which equals 7. That's correct. Very good job, William. So you have a very good fundamental grasp of substitution. Congratulations. After this, we're going to teach one more technique about how to solve linear systems, known as elimination. Most kids like elimination more because it's faster. But
can I solve mine?
Yeah, of course.
X equals 3 and y equals 5.
5. Okay. Did you double check your answer? That's a no, but I think it's the right answer anyways. But always get into the habit of double checking your answer. 3 times 3 is 9. Take away 4 is equal to 5. Checks out for the first one. 3 plus 5 is equal to 8. Checks out for the second one. So that means your answer is correct. Very good job, Jeremy. You also have a good fundamental grasp of substitution. Sherry?
Yeah, so I haven't done the this in like 2 months, but for y, I got y equals -1/3 plus 4/3x, and then yeah.
What? Sorry. You mean for this one when you're rearranging it? Is that what you're talking about?
No, I haven't I've rearranged the that one.
Okay. Were you able to solve yours or no?
I was a bit confused with the fractions, so yeah.
Oh, okay. So let's go over yours together because yours is a little bit more challenging than Jeremy and William's. So let's do yours together. How about that? So this one is already very nice because they already isolated for y for us. Y equals to -2x plus 3, right? So you can actually just substitute that directly into here. We don't really need to rearrange anything. You could if you want to. It's the same thing. So I see no reason to, right? So we have 4x minus 3 times -2x plus 3 is equal to 1. That means 4x plus 6x minus 9 is equal to 1. That means 10x minus 9 is equal to 1. 10x equals to 1 plus 9. X equals to 1. Does that make sense? Did I make a mistake anywhere, Sherry?
Oh, yeah.
Does this make sense? All you have to do is replace the y with -2x plus 3. And then the hard part is making sure that you distribute the terms properly. Okay, -3 times -2x is positive 6x. -3 times positive 3 is -9. So we end up with 10x take away 9 is equal to 1. X is equal to 1. Once we have x equals to 1, replace it into equation number 1 or 2 in order to solve for y. So y is equal to -2 plus 3. Y therefore equals to positive 1. So we have x equals to 1 and y equals to 1 as our final answer. And again, on a test, I recommend substituting into equation number 2 as double check. So 4 minus 3 is indeed equal to 1. So I know this is the correct answer. You could rearrange it if you want to, Sherry, but in this case, I don't recommend doing so because it's not necessary because they already isolated y for us, right? So in this case, it's probably better to just substitute directly. Let's go over the second technique now. You guys are very good. Very, very smart for students that didn't even learn grade 9 math. I'm very impressed. That being said, I'm not saying you guys should skip grade 9 math. Like grade 9 math still teaches you guys all the good tricks on how to graph the linear equations, right? Because if you don't know those tricks, graphing some of these things is gonna be a little bit painful for you guys. We're gonna learn the second strategy, which is known as solving by elimination, okay? So again, I'm going to go back and we'll use the exact same example as the cell phone example. So we have y is equal to 2x, and we have y is equal to x plus 10, okay? We already solved for this before. We know that x is equal to 10 and y equals to 20. But is there another way to solve it? And the answer is yes, there is. We can use a strategy known as elimination. This is strategy number 2. Most students like to use this one, okay? And how we do it is we line the two equations up next to each other, or rather not next to each other, but rather one on top and one on the bottom. Then we make sure that either the x or the y has the same coefficient, and that's a number in front of them, okay? So in this case, this x has a 2 and this x has a 1. So if we wanted to eliminate the x, we would have to multiply the entire equation, the entire bottom equation, by 2, so that we can end up with 2y times 2x plus 20. That way, when I subtract these two equations, I can eliminate the x. It's not necessary in this case, though, because it's nice because we have y's lined up over here, and both y's just has a coefficient of 1. So what I can do is I can actually just subtract these two equations. Y take away y is equal to 0. I put the equal sign here. 2x take away x is equal to x. And 0 take away positive 10 is negative 10. So therefore, 0 is equal to x minus 10. So therefore, x is equal to 10. And therefore, y is equal to 20 after we plug this back in. So elimination is usually a little bit faster. It does involve placing the two equations one on top of the other and making sure that there is a common coefficient for us to eliminate. So again, if we were to take a look at this question and somebody said, oh, I don't want to eliminate y. I hate x. I want to eliminate x. Well, that's okay. We can multiply the entire bottom equation by 2. Do the same thing, we subtract. Y take away 2y is negative y. 2x take away 2x is equal to 0. And 0 take away 20 is negative 20. So we end up with negative y is equal to negative 20, and y therefore equals to 20. And then we can plug it back in to solve for x. So it doesn't matter which one you choose to eliminate. You will be able to get the exact same answer. Let's practice a little bit of elimination. Again, Jeremy, you can do number 3. William, you can do number 4. And Sherry, you can practice number 5. Remember, guys, the trick for these questions is to eliminate one of the variables. And to eliminate them, you need to make sure that they have the same coefficient. Or they can be different signs. If they have different signs, like one's a positive 2 and one's a negative 2, you can add the two equations together in order to eliminate them. Okay, so elimination doesn't always necessarily mean subtraction. You can add them. Okay, seems like you guys are taking a little longer with this one, so maybe you guys don't like elimination as much as I thought. Maybe you guys prefer substitution.
I'm just kind of confused at one part. Like,
Sure.
to
How
use
about
elimination, you just stack them on top of each other and then just, like subtraction, right?
That's not exactly what I said. Remember the part I said about the coefficient? They have to have the same coefficient before you either subtract or add them. Because right now, if you subtract them, you're not going to be able to eliminate anything. You haven't eliminated any of the variables. In order to use the elimination, you have to make the coefficients the same. So for example, if we take a look at 4 and 6, the lowest common multiple between them is 12, right? So what I need to do is I need to multiply the entire equation on top by 3. So multiply every single term by 3. At the same time, I need to multiply every single term on the bottom equation by 2. That would give me an equation, a coefficient of 12 for the x's, and then I can subtract them to eliminate it. Does that make sense, William?
Okay, yeah, I get it now.
You get it? Okay. So that's why we call it elimination. You have to eliminate one of the variables. If you just try to subtract it or add it immediately, unless you are very, very lucky and the question was structured that way, you will not be able to get an answer because you're going to end up with one equation with 2 variables, right? And that never has a solution. We need 2 equations in order to solve 2 variables. Similarly, if we have 3 variables, you need 3 equations to solve.
Wait, so then would it be negative 11y equals 45? Or?
Oh, okay. I haven't done the calculation, so let's take a look. So yours ends up with 12x plus 21y is equal to 69, right? And in the second equation, we end up with 12x minus 10y is equal to negative 24. So in this case, we're going to eliminate the x's, so we're going to subtract them. 12x minus 12x is 0. 21y minus negative 10y is equal to 31y, right?
Yeah.
Y. And then we have 69 minus negative 24, so that's...
Wait. 21y minus 10y is...
No, minus negative 10y.
Oh,
minus
okay.
negative 10, right? So it's positive 31. So you end up with y as
okay.
Does that make sense? You do have to still remember your basic integer operations.
Okay, yeah, I get it.
All right, so we have y equals to 3. Substitute it back into equation number 1 or 2 in order to solve for x. Okay?
Okay.
So again, you guys learning this right now is way beyond your time if you guys aren't planning to do IB math. Because to be honest, if you guys are just in the public school system, you're not going to be able to use this for another year, right? Because for 2 of you, you're going to grade 9 next year, you're not going to use this. So once you do practice this a little bit more in grade 10, it's just going to become second nature. It's going to be very easy. So then you guys won't even have to think about this. It's going to be like as natural as breathing, okay? So right now it might be a little bit difficult, but that's okay. That's why you guys are doing this this trial class with mentors, right? It's really just to get a taste of grade 10 math. No one's expecting you to walk out of this having mastered this type of technique, okay? Jeremy, have you managed to solve for your answer?
Not yet.
Not yet? Did you want to keep trying or do you want me to take it up with you?
I'll do it for 5 more minutes.
5 more minutes? Okay, I like your spirit. Good job. And Sherry, have you figured out your answer?
I don't usually use the elimination method, so...
Oh, you learned this before? You usually use substitution?
Yeah.
Oh, so you've already learned this. Okay, so your math is a little bit more advanced than I thought. In which case, if you don't use elimination, did you want me to take it up together with you, or do you want to?
Yeah, it's actually pretty new to me. Like elimination, I've never done.
Okay. Unfortunately, once you're in school, on the test, the teachers, for a part of the test, they'll say that you have to solve a substitution or that you have to solve an elimination. So they will specify. So it's not like we can just choose one or the other. So we do have to know both. And then when it's a word problem and the teacher doesn't indicate which technique you must use, in which case it's your choice, okay? It's free for all. But you do have to know how to do both. So remember what I told William up above. The first thing that we need to do is to find the same coefficient. So we have the two equations. We have 5x minus 12y equals to 1 and 13x plus 9y equals to 16. First question that you need to ask yourself, Sherry, is which one do I want to eliminate? Do I want to eliminate the x or the y? Which one do you dislike more?
I feel like a y would be better.
Okay, so let's eliminate the y's, okay? So we have 12 and 9. What's the lowest common multiple between 12 and 9?
Let me see.
36, right?
Oh, yeah, 36.
Okay. So what we can do is we can multiply the top equation by 3 and the bottom equation by 4. So let's multiply the entire top equation by 3. We end up with 15x minus 36y is equal to 3. The bottom equation we're going to multiply by 4. So we end up with 52x plus 36y is equal to 64. So far, so good?
Mm-hmm.
Now this time, if we want to eliminate it, am I going to add the two equations or am I going to subtract them?
Add them.
Add them, very smart, because we have a negative 36 and we add 36, so that way we get 0y. So we have 15x plus 52, which is 67x, plus 0y is equal to 67. And obviously x is equal to 1 at that point, right? Now that we have x is equal to 1, so I'll get back into the equation either 1 or 2 in order to solve for y. And I'm not going to do that because you know how to do that, right?
Mm-hmm.
So that's how we do elimination. So you can see elimination would actually be quite fast once we get used to it. Because when you're using substitution in this case, you do have to isolate for the variable. And it gets a little bit complicated because there's usually a fraction involved, right? So it tends to become a little bit messy when we're writing it. In which case, elimination is probably the better option to use in order to try and prevent possible mistakes. Okay. So really good job, Sherry and William, for the attempt. I do think you guys understand how to do it. And again, with a little bit of practice, it's just going to become second nature to you guys. I mean, you guys won't have to think about it. But just bear in mind that whenever we're solving linear systems, there is, I guess, 3 solutions to it. One is graphical, which is the worst solution because nobody likes graphing, right? The second one is substitution, and the third one is elimination. Elimination is generally the fastest, but I find substitution to be the best. Okay, so we're gonna give Jeremy one more, let's say 10 more seconds to finish up his question. Did you manage to solve yours?
Oh, I solved it.
Congrats. Okay, what's yours? What's your answer?
Y equals 2.5.
Okay. And x?
X. I don't know.
Okay. So you said y is equal to 2.5. So again, we can still solve for it because you just plug it into over here, right? So 2.5 times 2 is equal to 5. So we end up with 5x plus 3 is equal to 4 times 2.5. 2.5 times 4 is equal to 10. So therefore, we have 5x is equal to 7. X is equal to 7 over 5. And your y is equal to 5 over 2. Once we are in high school, Jeremy, write everything as improper fractions. All your answers need to be labeled as improper fractions. We do not like to use decimals. And for those of you who are coming out of elementary and you're used to doing mixed numbers are garbage. We do not use those in high school, okay? We only use it for one time in grade 9 and never again. So I'm not sure why they teach it. I didn't double check your answer, Jeremy. I know it satisfies the first equation, so let's double check the second equation, okay? So we have 3 times 7 over 5 times 5 over 2 plus 2 must equal to 5 times 5 over 2. 5 and 5 cancels out, so we end up with 21 over 2 plus 2, which is 4 over 2, must equal to 25 over 2. And that does check out for left side and right side. Since left side is equal to right side, your answer is correct. So this is the right answer. But just remember, you still have to plug it back in order to solve for the x. But good job solving for the y. You probably figured out that you have to eliminate the xy, right? And then afterwards, I
didn't know. I didn't know you could do that.
Yeah, you have to eliminate for the xy. If you leave the xy, then you're not going to get anywhere, right? Remember, we're going to end up with one equation, so we need one variable. Otherwise, we're in trouble. Okay? Because remember, if you have two variables, you need two equations to solve it. You can never solve. Otherwise, you'll never get one answer. Okay? I think that's it for today. I saw Michael rejoining us a little bit earlier. Thanks to everyone for paying attention to me for the last hour. Hopefully you guys learned a little bit of something about substitution and elimination. Hopefully the lesson made sense. And have yourself a good rest of the night. Oh, I think Michael wants to just speak with you guys real quick, okay?
Oh, that's okay, Michael.